The search for signs of intelligent life on other planets should take into account the lights of cities. This is what a study published in the September 2022 edition of the scientific journal Acta Astronautica suggested. Similar to Earth, during the night when the dark side of the planet displays clusters of city lights, advanced civilizations on exoplanets may have built illuminated urban complexes on their surfaces. The lights of cities represent technological signals that, until the beginning of the operations of the James Webb Telescope in July 2022, could not be detected by astronomical means. Previously, space research focused on detecting other technological signals such as radio signals and atmospheric gases like nitrogen dioxide. Regarding radio signals, the first radio telescope in the world was built in the 1930s by the Bell Telephone Laboratories in the United States. These devices are used to detect extraterrestrial radio signals, including one we have already discussed here on the channel, the WOW signal, one of the most famous signals ever detected. Regarding gases, the production of nitrogen dioxide on Earth currently includes biogenic and anthropogenic or human-made sources, as well as lightning. However, anthropogenic nitrogen dioxide dominates 3 times the amount of non-human sources. Detecting levels above non-technological emissions found on Earth could be a sign that the planet may host active industrial processes, explain the researchers. In addition to radio signals and gases, light signals can also be an indication of technology and can now be detectable by NASA's new telescope depending on their wavelength. These more urbanized planets would have a higher nighttime brightness from city lights and would be easier to detect, write the authors of the cited study. Until now, it was a consensus that an incredibly powerful telescope was needed to detect these light signals coming from a potentially habitable exoplanet, and currently, the only telescope capable of this feat is the James Webb Space Telescope. With enhanced technology and a significantly larger collecting mirror compared to its predecessor, the James Webb Space Telescope surpasses the Hubble in various capacities. For instance, it can map a constellation of stars within hours and generate notably sharper images, exhibiting substantial differences in terms of depth and precision. In contrast, the Hubble required several weeks to accomplish the same task and provided images with lower resolution and acuity. According to NASA, however, the Webb does not replace the Hubble but serves as a successor with non-identical capabilities. The James Webb is dedicated to observing the universe in infrared light, while the Hubble will continue to study it mainly in ultraviolet and optical wavelengths, although it does have some infrared capability. This makes Webb's photos much sharper because its technique cleans interstellar dust from the images, whereas the Hubble does not. This also allows the brightness of some stars that previously appeared faded to be captured. Your incredible capability will even enable us to embark on a journey through time, as the telescope will be able to observe stars so distant that their light may date back billions of years. In other words, it will be possible to see the light from the earliest stars after the Big Bang. It was then that a surprising discovery occurred when the James Webb Telescope investigated the exoplanet WASP-39b, which had already been identified in 2013 by the Wide-Angle Search for Planets. Located approximately 1,140 light-years away from Earth in the Phoenix constellation, the telescope detected city-like lights on its surface. The planet was unveiled in an immediate and unprecedentedly detailed manner by the most powerful space observer ever launched, say NASA scientists. Webb detected the presence of water, clouds, and haze in the atmosphere around WASP-96b, in a measurement classified by experts as the most detailed ever made of a planet outside our solar system to date. The observation made by the telescope, which had images captured in observation reports released, detected the presence of specific gas molecules based on small decreases in the brightness of captured colors, from the formulation of the most detailed light spectrum to date. These colors, in turn, provide clues about the propagation of light in the atmosphere of WASP 96b, which would mean that there is light emitted by it that does not originate from an external source such as its star, WASP 96, around which it orbits, or another celestial body. Therefore, Webb can search for biosignatures by studying planets as they pass in front of their stars and capturing starlight filtered through the planet's atmosphere. Although it's not possible to obtain detailed images like those captured by a satellite orbiting Earth, the James Webb Space Telescope has taken a significant leap forward by providing crucial data for scientists. In the near future, this data may allow us to determine whether the detected lights could be considered biosignatures of an active planet, whether through alien cities, volcanoes, or other forms of luminous activity that are still unknown. Theoretical calculations indicate that there are approximately 300 million potentially habitable planets in the Milky Way alone, with several Earth-sized habitable planets located just 30 light-years away from our planet, essentially making them galactic neighbors of humanity. However, WASP 39b orbits very close to its star, about 1/8 of the distance between the Sun and Mercury, and its mass is approximately 1/4 that of Jupiter with a diameter 1.3 times larger, making it hotter than what is considered suitable for harboring life. These initial data demonstrate that the James Webb is capable of detecting chemical signals from light originating from exoplanets, and in the coming months, it is scheduled to turn its mirrors towards other exoplanets such as TRAPPIST-1e, an Earth-sized and potentially more habitable planet. Although with this data we cannot directly attribute the lights to the existence of cities and civilizations, the next generation of exoplanet studies may provide the extraordinary evidence we need to prove the existence of life beyond Earth. And the initial data obtained by the James Webb Space Telescope give us a glimpse of the fascinating progress ahead. What do you think? Are we close to finding cities on other planets? Share your opinion in the comments. These and other cases are showcased here on the Mystery Machine channel. If you enjoy this type of content, please subscribe,